Can you visualize complex modulo-N counter outputs? Imagine watching a digital counter in action, but instead of simple counting, it jumps through a series of states that seem a little tricky to follow. That's where visualization comes into play. When dealing with complex modulo-N counters, it's all about making those state changes clear and easy to understand. These counters count from 0 up to n-1, then reset and start over. The number n is called the modulus, and it determines how many states the counter goes through before restarting. Usually, these counters are built using flip-flops, which are tiny electronic switches that store 1 bit of information each. The number of flip-flops needed depends on n. For example, if n is 10, you need at least for flip-flops because 2 to the power of 4 is 16, which covers all 10 states. Visualizing these counters can be done in several ways. One common method is the state diagram. Think of it as a map where each circle shows a specific count state, and arrows show how the counter moves from one state to the next with each clock pulse. For simple counters, this is straightforward, but for complex ones with irregular sequences, the diagram helps clarify the order and reset points. Timing diagrams are another useful tool. These show how each flip-flop's output changes over time, giving a clear picture of the counting process. For example, in a counter that counts from 0 to 9, the waveforms will show the binary pattern changing from 0 to 1001 and then resetting. Truth tables and excitation tables are also helpful. They list the current state, the next state, and what inputs the flip-flops need to make that transition happen. These tables are especially useful when designing counters with custom or nonlinear sequences. Lastly, circuit diagrams show how flip-flops and logic gates connect to from the counter. Seeing these connections helps troubleshoot or modify the circuit. In real-world applications, engineers often use simulation software that can animate these diagrams, showing state transitions and waveforms dynamically. This makes understanding complex modulo-N counters much easier. For counters that skip certain states or follow special counting sequences, visualization confirms that the design works as intended. For example, a modulo-F counter counts 0 to 4, then resets, and its diagrams will clearly show this cycle. So, yes, visualizing complex modulo-N counter outputs is entirely possible and very helpful. Using state diagrams, timing waveforms, truth tables, and circuit schematics, engineers can see exactly how these counters behave, making design, analysis, and troubleshooting much simpler.